We're going to be looking at uh, optimizing area, and we're actually going to use a program called Scratch. It's a block-based programming program. It's on the web. It's a web application. And before we get into the programming and how to build a program to help us with our optimizing of area, we're just going to talk about the general idea, what the mathematics is behind what we're going to try to attempt. So we're going to try to get the Scratch program to build a table like this. It'll be called a list in the program. Then we're going to get it to populate values within these columns here, so that we can explore the different types of areas we'll get when our perimeter is constrained. So when you have like a set perimeter. So imagine, we have maybe something like here is 24 meters of fencing, we'll say. So we'll say here's all of the fencing we have. That's all of our material, 24 meters of it. And so that's going to be our very first input in our perimeter. What's a possible length? Well, we could build a fence, and we're going to be building rectangular fences in this case, okay? So we could build a fence where it's a meter. It's 1 meter long there. And then if that side's a meter long, then we know the other side is a meter long also. So that's already 2 meters missing. So that leaves us, so remember we started with 24. So we had 24, we've subtracted now 2 meters, there's one on each side, we're left with 22, and we need to split that between the two sides of the rest of the fence. So if we were to divide that by 2, the other two sides of the fence will be 11 meters each. Okay, and if you're unsure about that subtraction and division, you can kind of just add them all up now that we have it. So this will be 11 meters, and this will be 11 meters. Okay? If you add them all up, 11 and 11 is 22, 23, 24, 24 meters of fencing is used. But there's many different shapes we can build like this. In fact, we could use decimal values, but we're going to use whole values as we go through this. So that would have been a length of 1. We'll say the width was 11. And in that case, well, the area is only 11 meters squared. Great. So let's go into our Scratch program to try to build these lists here. Okay, so let's take a look at it. Jump over. Okay, so here's Scratch. This is the type of page you would start on. And here we have a whole bunch of overarching categories of blocks. It starts on the motion blocks. And here's where we kind of see what our code does. This is our interface of what's happening. Okay. First thing I'm going to do is I'm going to focus on this area here. This area here is where we put our code, or our script as they call it in Scratch. In fact, I'm going to make this part even larger. As you'll see, I'll go back there. Just a little arrow. It's hard to see just beside the X and Y coordinates there. And if you select it, it gives us our area where we're going to put our block-based coding. It makes it much larger, which is much easier to work with. Okay. So because of that, so on our interface screen here, we have the cat from Scratch. Probably name Scratch the cat. We actually don't need this guy. And you'll notice they call it a sprite. It's an object that works within our program. If we right-click on the sprite in this section down here, you can actually hide them. And when you hide them, they'll disappear from our interface screen. So when I hide the cat, there we go. So there's nothing there. And we actually don't need anything to be there. The reason being is that we're going to have lists come up in this part. So when we get those lists up, we only want them to show. We don't need that sprite actually showing up. The first set of blocks we're actually going to take a look at are actually going to be the data blocks. You'll see I just kind of highlighted them there. Those are going to be the first set of blocks we're going to look at. So when we select data blocks here, you'll notice it starts off as empty. There's nothing in there. And like I talked about, we're going to make tables or lists. So we're going to select the Make a List button here. And we're going to give our list a name. Well, the very first list I think we had was length. So we're going to call our first list length. And right away, it populates. First of all, in that screen, you'll already see a list underneath. And I'm just going to make it the length of the screen here. And when we look at the blocks here, they've already auto-populated a bunch of blocks for us. So there gives us our first list. In fact, we're going to have 4 lists. We have one called length, one called width, one will be called perimeter, and the last one we'll call area. And if you notice, we go back into this interface, I can actually move these around. I'm going to move area farthest to the right, slide perimeter in here, and I'm going to pull them the length of the screen. Now, these lists are technically empty at the moment, but we're going to input some script that's going to put information into these lists. These lists, a list in Scratch is a place where you can like archive information. You can have information go in here and keep record of it, and you can have it show for people, or you can have it not show. You'll notice I can turn the area list off and it disappears here, okay? Now, the first way I'm going to start my code is I'm going to go into events. The events are the blocks here in the top right, and you'll see they've populated a new set of blocks. In fact, anytime I go into a new category, I get a new list of blocks underneath that category. So in events, the first block we want to look at is when flag clicked. So when that green flag clicked, I'm going to drag that into our block base space, and when that block there refers to this green flag. So when we click that, that's going to execute whatever code we put below this. Events or event blocks are essentially blocks that communicate messages back and forth, and whether they're messages to start something or to stop something, a lot of that can be done within this space here. Okay, we're going to go back to our data here, and now that we have our list, the very first thing I actually want to happen is I want my list to clear every single time I start this green flag. So maybe I've ran this program once in the past. I want all that information to disappear when I hit this green block so that it can start fresh. So I want to use the delete block here. So I'm going to drag it in. And you'll notice there's this little indent in the delete block and this little part that sticks out so that they click together. And you'll see it's a little hard to see, but it highlights white, meaning that these will click together. I can pull them apart. That means they're not working in unison. And if I put them together, they snap together and they work. If at any point I don't know what a block does, I can right-click on a block, and you'll see under Help, it'll populate a window to the right and tells you. So that's what the run the script when the green flag is clicked. That's what that block does. The delete block, we can do the exact same thing with Help, and it gives us a big list of what this block potentially could do. Now, I know a little about it, so instead of deleting the last thing in the list, I'm going to delete all of that list. And my first list is length, so I'm going to start off with length. Now, it doesn't technically matter the order I put these 4 delete blocks in. So I have 1 delete block for length. There's going to be 1 delete block for width. And again, all that does is clear those columns when we first do this. And I know you're thinking, why am I clearing stuff? I don't have anything in there yet. But that's because when we want to run the code, we don't want any information from the last time we ran the code to still be sitting in there. Okay, so I'm going to put our 4 delete blocks in, change it to null, so delete all of it, and we're going to delete length, width, perimeter, and area. Great, so we have a good start already. The next thing we're going to want to look at is making a variable. So I'm still in this data, or block, or sets of blocks that are under the name data. We're going to make a variable, and not only do we have a list with the names area, length, perimeter, and width, we're going to do the exact same thing with variables. So I have a variable called length. Oh, did I make a list? Whoops. Name is already taken. Okay, let's make a variable. We'll call it length underscore 1. We'll call it length 1. Perfect, there you go. Now we've made a variable called length 1. And just put it down there. And again, if you notice, I can have that variable. A variable block can have many different functions. You'll notice when we make one, it gives us another 4 sets of blocks that we can do around this variable. This variable, just like in mathematics, could be anything we want it to be. So I'm going to make all 4 here. Width 1, I'm going to call it, just because I was running into a problem there of already using the name. So I just add a little something to the end of it. And finally, area. Okay, so I now have my 4 variables too. Okay, these 4 variables are going to be pretty important to us. We're going to use them to essentially populate these lists. These variables are going to continuously change, and every time the variable changes, a new part of information will end up going into this list here. So within the variable blocks, we have a block called set. And what that is I'm going to set one of my variables. In fact, I'm going to set our perimeter variable equal to something. And if you recall at the very beginning, we talked about having a set perimeter of 24 meters. So the perimeter in this case is going to be set to 24 meters. That's going to be like our constraint around our different areas we're going to find. Along with that, I'm also going to set, and you'll notice the set block is the same. I just have to change which variable I'm setting. I'm going to set the length equal to, and the very first length we had was 1. Now, technically, I could start it at 0, and we know that that would not be a rectangle. And then you can have all of them populated. We'll start it with 1 here, okay? So we're going to start in there. Good. The very first length we're going to use is 1. That's going to be our constraint. Now, the next thing I need to do is I need to essentially have a formula that sets our length equal to some formula with width involved. So what do I mean by that? I need to show you this actually. Okay, so our width here, we need to come up with a formula for width. It needs to be a formula in respect to our length and our perimeter, and then we're going to talk about our area formula also. So we need to build some formulas. We know that our perimeter formula, okay, is written as P is equal to 2 times our length plus our width. Sometimes that formula is kind of written like this, 2L plus 2W, but this is the specific version of it we're going to use because this one is going to be the easiest to isolate, okay? So remember I said I wanted to isolate for width in this case, okay? That means I need to move everything over to the other side of the equation. I need to get width by itself. So in order to do that, right now I have P is equal to 2 times this, so think of like a bit of a reverse bedmass here. We need to get this 2 multiplied by these brackets. I need to move this 2 over. So because it's multiplication on this side, when I bring the 2 over, it becomes division. It's essentially dividing both sides by 2 to turn that 2 into 1, but think of it like this. Opposite operation, take the 2, because it's multiplication here, we divide by 2. So our formula now reads at the moment, our perimeter divided by 2 is equal to our length plus our width. Great, but remember I had to isolate W, width. So now I need to move the length to the other side. In order to do that, because it's a positive here, when I bring it to the other side, we're going to be subtracting by length. So our new formula reads P divided by 2, subtract length is equal to W. Perfect, I'm done. Okay. We just have to make sure we set the order of operations up properly because the computer is very specific with that. In our case here, we know that division comes first, but I'm going to put a set of brackets around it because it's going to help communicate this idea when we actually go to build it in Scratch. So the very first step we're going to tell the computer is to divide the perimeter by 2. Remember, we've already set the perimeter equal to a value. And then we want it to subtract by whatever our length was, and we've already set that to a specific value. We're building our constraints at the moment. The other thing we need to state is our area formula. And our area is equal to length times width, okay? And that's fine. We don't have to manipulate anything there because if you think back, we set perimeter to 24. We set our length to 1. So here we go. We can say perimeter variable, check, we got something. Length, check. We now have something for width, which we're going to build into Scratch. And area, well, it's referring to length and width, which we already have something for, so this is going to work out perfect. So we need to go set those variables in our new, in our Scratch program here. What we're going to do is we're going to set our other 2 variables equal to something. So if you remember, we had width, which we just built a formula for, and we have area. We're going to look into the operators blocks, okay? That's going to help us set things equal to. So we click under operators, you see we get a lot of our mathematical type of blocks, we'll call them, okay? So we're going to set width to what? Well, width is going to be equal to our formula we built. And remember, our formula was P divided by 2, okay? So in case you've forgotten here, the formula was P divided by 2, and that's going to be the first set of it. Subtract our length is equal to our width. So how do we build such a thing? Okay, let's take a look. So we look at our operators. Division. Well, here's our division one. I'll pull out our division operators and go back to my data. P, which was our perimeter, so there's our perimeter block. When we go to slide it in, we actually come from the right to the left. You'll see the highlights. If we go from the left to the right, it doesn't seem to work very well. We can't really drop it in. So on Scratch, we go from right to left, and it highlights, and now I can drop my perimeter in. So perimeter divided by, and I'm going to say the value of 2. That was the first thing I wanted to do. And then we need to subtract. Well, I got to go back into my operator blocks. I get my subtraction block. I'm going to pull this entire division block. Think of this block now as a set of brackets telling the computer execute perimeter divided by 2 first. So I take that and I slide it in from the right here. See how it highlights? I drop it in. And it has to subtract, well, whatever our length is. So I'm going to put the length block in that slot. So now our order of operations is perimeter divided by 2. And then subtract whatever the length is. Perfect. So we're going to set width equal to that. So I grab the lowest block here, which is the subtraction block, and I slide it in from the left into that square, and boom. Width is equal to perimeter divided by 2, subtract length. Again, I do have to snap it in here to get it to go, but there's going to be a little trick around this in our program because we want this to continuously happen. We're going to have to use one of our control blocks here. Area, if you recall, was just multiplication. So I go and I grab my multiplication block. That's that little asterisk or star looking block in the middle of those 2 circles. And it is length times width. So I get my variables, my length variable, and I drop it in. And I get my width variable and drop it in. Now, we want width to be defined before area. So, sorry, let me drop this into the area. So area is now equal to length times width. If I were to put the blocks in this order, it would tell me to multiply width, but I haven't defined width yet. Okay, so I actually want my area block, the one where I set area equal, below my width block. That way I've defined width. Now the computer has a definition for it, and then it can give whatever that value is, that new width, times that length. Okay, so it's very actually important the order we drop these things in. Okay, so once we have that, remember we said the perimeter is 24, so it's going to be 24 divided by 2. Subtract 1. Is going to give us your new width, okay, and width will be 11 times 1 length. We now have our area. Great. So we're going to go back into our list. Now that we have our new area, we want to add to our list here. So add. We're going to add to our length width. We're going to add the length. We're going to get our block for length. There we go. So now add whatever our length is to our length list. So we'll get out something populating in here. And we're going to duplicate that again. Add the width to the width list. Add the perimeter to the perimeter list. And add the area to the area list. Great. So once everything's been defined, it's going to add those values into each of our lists. That's great. Okay. And once we have that, everything's going to calculate. We're set up very nicely. I want it to then happen many times over. In fact, let's take a look. We're going to use a repeat. This block here tells the computer to execute a set of commands over and over again a certain number of times. And remember, if you ever need help, just right-click on the block. Help gives you a big definition of what runs the block inside a specific number of times. Great. Okay. We're going to run ours. Oh, I'm not quite sure, actually. Let's see. I think 10 times is actually going to be pretty good in this case. We're going to repeat this 10 times, this set of blocks within. Okay, so when I go to snap this up, it's going to run these 10 times over. But I don't want it to run the same thing 10 times over. Okay, this is where the little trick comes in. At the very end of the command, I want to change. And I'm going to change the length by 1. So this is where that's going to execute that stuff for us. We're going to change the length by 1. So length is going to increase to the number 2 and then recalculate. Then to number 3, then recalculate. We can have it wait 1 second just so we can see it happen every time. But when we do this, we should be able to execute this, and it's going to populate all of our lists now. Okay, so let me demonstrate here and give it a try. I'm going to repeat to 11 very quickly. I execute it and realize I needed one more. But these are our blocks. Let's execute. We're going to hit our green flag and see what happens to our lists. So see our list. There we go. Length is 1, width is 11, perimeter would be 24, area is 11. It constantly changes the length. We're getting a new value every time. You'll see the width is adapting because of it, because we set our constraint here. Perimeter never changes. We still have 24 meters of fencing. But the area changes depending on what type of rectangle we built. And you'll get to start to optimize. Well, if we want the largest area, we're looking at, look at this, a shape that is 6 by 6. Well, that's a square. Great. We've just discovered a square is the most optimal four-sided shape when we're constrained with perimeter. It gives us the largest area. Okay, and in this program, what we can do is we can change this. Maybe we want it to go, oh, I don't know, we want it to have a perimeter of just 20. I'm going to start a length at 0, okay, just so we can see when we have an area of 0. I probably won't need to go as many times. You know what? We'll execute by 11 anyways, just to see, so we get our extra ones here. Let's try it one more time. So fire it out. When the length is 0 and the width is 10, well, our area is 0, doesn't make sense, right? So here's our first one. Length 1, width is 9. Does that make sense? 99 is 18, 1 and 1 is 2, 18 and 2 is 20. Perfect, ran great. Click it, executed a perfect number of times here. Perfect. And we take a look, well, we get our 5 by 5. So a student could discover this. This is a nice model for a student to figure out, oh, okay, it looks like squares are going to be the best shapes for optimizing our area.